Okay guys, welcome to part 2 of the topic of forces. So in part 1, we did the first learning outcome, we did the second learning outcome, and we did the third learning outcome, or learning intention, sorry. So we just have the fourth one to do. For the keywords, balanced, forced, friction, and acceleration. So we're going to look at weight this time. So we're going to look at what is weight, what does weight mean, and we're going to look at the elasticity of a spring. Okay, so there's a few things, there's two kind of key things left for us to do, but we made good progress in the last video. So we're going to start straight into it. So this topic won't be 20 minutes. Well, it'll be just about 20 minutes. Okay, there's a few maths questions, but nothing major. Okay, so your heading here, guys, is weight. Okay, right. So the Earth's gravity, okay, pulls everything on the planet towards the center. So everything on the Earth is towards the center. So when you're standing up, your feet and your head form a straight line to the center of the Earth. Okay, so everything on the planet is being pulled down to the center of the Earth. Now gravity isn't that strong, because if it was, you wouldn't be able to stand up. So the fact that we're standing and sitting, okay, shows that we're able to defeat gravity all the time. Okay, all right. So gravity is what's pulling you down. All right. So the larger the mass, the larger its weight will be. Okay. So what's happening is that your gravity is affecting you. Okay. So your weight is affected then by the amount of mass you have. All right. So for example, the gravity on Earth is the same everywhere on Earth. Okay. Well, obviously, we'll get into it later. But the higher up you go, it starts getting less. But that's a topic for Earth and space. Okay. But generally, rule of thumb. All right. So if all of a sudden your weight starts to go up, it's not because there's a change in gravity. It's because you've got more mass. So the more mass you have, the higher your weight. That's why trucks and things like that weigh a lot more than bicycles, okay? Because they got more mass and the gravity is pulling it down, okay? So what is the definition of weight? So take this last point down. The weight of an object is a measure of the force of gravity on it. So the weight of an object is a measure of the force of gravity on that object. Okay? Now the misconception we have is we like to think that weight is in kgs. It actually isn't. We'll explain why in a minute, okay? So, take down the last point, same heading, okay? What I want you to take down here is these 3 points. We can therefore state that the weight is affected by 2 factors. Number 1, the mass of the object, and number 2, the force of the object, force of gravity. So what you need to do, guys, if you have 2 of the 3, you need 2 of the 3. You need to know what the mass of the object is, and you need to know what the force of gravity is. Because in Earth and space, the question you can get asked is, how would your weight change if you were on Jupiter? How would your weight change if you were on Saturn? How would your weight change if you were on the moon? And they'll give you the gravity on those planets. And all you have to do is multiply the mass by the gravity of those planets. That's it. That's all it is. Simple calculations. Nothing major here. Okay? All right? So that's weight. Take down those 3 points. And as you can see here, we have Neil Armstrong and Buzz Aldrin. So Neil, I've lost so much mass since coming to space. And then Buzz, you didn't lose mass. You're on the moon. Okay? So you don't lose mass. You actually lose weight because you lose gravity. That's why they're weightless. So they still actually have the same mass. They're just weightless because gravity is less. Okay? Right. So if mass is measured in kgs, all right, so this is the problem. So if mass is measured in kgs from first year, what would we measure weight in if it's a force? Well, all forces are newtons. So take down the second point here. Okay? Weight would be measured in newtons, N, like all forces. So the SI unit of weight is not kg, it's N, newtons. All forces are newtons. So if mass is in kg, it's force, it's therefore, mass is in kg, okay? And weight is a force, so therefore weight has to be newtons. It can't be kg, mass is kg, okay? So for Junius Earth, what we say, for the Earth, the force of gravity is 10. So take down this point as well. So for Earth, we say that the force of gravity is 10 meters per second squared. Okay? Now, it's actually 9.8. You learn that in Leaving Cert. But for Junior Cert, it's 10. Now, in the exam, if they don't give you 10, give whatever value they give you. But generally, it is just 10. Okay? For Junior Cycle. All right? So take down this then. This is your maths equation then. So this is the only calculation you need for this topic. The weight on Earth is the mass in kgs multiplied by 10. That's it. Mass in kgs multiplied by 10. That's all you have to do. Get the mass, get it in kgs, and multiply by 10. That's it. You're done. Okay, so just take down those points there. Oops. There we go. Okay. Now, quickly do these calculations for me there. All right, so I'm not gonna, you don't need to take this down, just quickly do them there. So on Earth, what was the weight of the following objects? A rock of 10 kg, a book of 40 grams, and a car of 500 kgs. All right, so again, look at your equation. All right, our equation is weight equals mass times 10. So I'm going to do number one. Oops, that's not number one. There we go. Number one, number two, number three. So number one, okay, a rock of 10 kgs. So the weight equals 10 multiplied by 10, which gives me 100 newtons. So the rock of 10 kgs is 100 newtons. Done. So that's number one. Let's look at number two. Oh, I keep hitting the wrong button there. Number two. A book of 40 grams. All right, well, first off, we need to change this to kgs. Okay? So 1 kg equals 1,000 grams. Okay? All right? So, okay, actually, I better show you how you calculate this. All right, so I'm going to give you 1 second there now. So I'll do a quick bit of maths for you, show you this, how you convert. All right, so if 1,000 grams equals 1 kg, okay? So 1,000 grams equals 1 kg. What would 1 gram equal? So if 1,000 grams is 1 kg, what would 1 gram equal? 1 gram would equal to 1 divided by 1,000 kgs. Okay, you just divide across. So what would 40 grams equal? Well, 40 grams would be 40 multiplied by 1 over 1,000 kg. You see? So that will become, let me do my own calculations there. Well, actually, it's easy enough. You divide by 1,000, 0.004. Oh, I have too many zeros. Oh yeah, sure, there's only 1, 2, yeah. So 0.04 kg. So that's where it comes from, okay? All right? That's one way to look at it, all right? So I'm trying to just explain it to you another way, okay? Now, another way to think of it is we did before. That's one way to do it, if that's a fail-safe, all right? Another way to think of it is this, all right? I said 1 kg equals 1,000 grams, okay? So 50 kgs, all you do is you multiply by 1,000, so you get 50,000 grams. So every action has an equal but opposite reaction, okay? So therefore, what we could say is, to make, all right, so let's say we have that, we could say therefore, so kg to g multiplied by 1,000, okay, not 600, 1,000. Therefore g, what we do with g to kg. So if kilograms to grams is multiplied by 1,000, if we're going grams to kilograms, what would we do? We would divide by 1,000. That's all you do. So if you're going grams to kg, divide by 1,000. Kg to grams, multiply by 1,000. Every reaction, equal but opposite reaction. Okay? That's it. So if you're going kg, if you go kilograms to grams, you multiply by 1,000. You're going grams to kilograms, you go the opposite, you divide by 1,000. So there's two different ways to look at it. Okay? The first way, I suppose, was just showing you the maths involved to prove it. And the second way then is, well, just a shorthand way. So therefore, what would this be then? All right? So our weight would therefore be 0.04 times 10, which gives us 0.4 newtons. And there you go. Number 3 then, so that was a bit long-winded to get there, but we got there. I know some of you might already know that math, but that's fine, just other people might not, okay? So a car of mass 500, that's simply going to be 500 kgs times 10, 5,000 newtons. All newtons. And there you go. Okay? All right. So there we go. There are your 3 questions and answered. Okay? Hopefully you got them right. Okay. So we got a good bit to go. What are we on? 10 minutes. Okay. So we'll try and pick up the pace a little bit. All right. So gravity is not constant throughout the universe. Okay, so gravity is not constant throughout the universe. Each planet has a different force of gravity, which will change your weight. Take that down. So our heading now, guys, is gravity. Okay, so we're tying in a little bit to Earth and space here, but that's fine. Okay, because it's still technically under weight, and gravity is a force. So gravity is not constant throughout the universe. Each planet has a different force of gravity. So 2 examples here, of course. Jupiter, it's 25 meters per second. On Earth, it's 10. So in Jupiter, it's 25 meters per second. So it's an extra, it's 15 meters per second stronger. And then look at the sun. Obviously, the sun has very strong gravity because the Earth has the moon, one moon flying around it. And even then, the moon is slowly moving away from us. Our force of gravity isn't strong enough to keep it. Whereas the sun is strong enough to keep all the planets stuck floating around it. Okay. Now, take on the last point as well. We will refer to gravity simply as g, small g. Okay, and you will often hear it referred to as acceleration due to gravity. Okay, so gravity will generally be referred to as just simply g. Okay, but a lot of times you'll hear the word acceleration due to gravity. It just means gravity. It just means multiplied by 10. That's all. Okay, because acceleration due to gravity, in other words, how fast does it speed you up? If I throw something up in the air, it'll accelerate back down at the speed of gravity. Okay, not the speed of gravity. Sorry, with acceleration due to gravity, not speed of gravity. That was right. Okay. Now, the key thing here, what you need to know is the difference between mass and weight. Okay, you need to know the difference between the two. So take down these two. Again, you won't be asked this, but it's more, just don't get confused. A lot of people get confused between them. All right. So what is mass? It is the amount of matter in a substance. It remains constant everywhere in the universe, and the SI unit is kg. What is weight? It is a measure of force of gravity in a body. It's dependent on the strength of gravity at the location. SI unit is newtons. Okay, you see? So that's important. All right, so take down those and then watch that video. That's a very good video explaining it in more detail. Okay, so the difference between mass and weight, just so you don't get them confused. All right, now, okay. So we're moving on now, guys, to a little bit more maths, and then we're going to be touching on the elasticity of objects, and then we're kind of done, actually. So the last thing then really with forces, okay? How can I calculate the amount of force I need to accelerate an object? Okay, so we're now stuck in a situation. The heading I want you to take down is this. Put this down as your heading, actually. Okay, it's shorter. Okay, so how can I calculate the amount of force needed for an accelerator? Or our heading, what are the two things involved in applying a force? What are the two things we need to be aware of when we apply a force? Okay, so number one, we need to know that the mass of the object, the more the mass, the more the force is required. So the two things that are important is the mass. Okay, so the heavier the car, the more driving force you'll need, the more fuel you use. That's why if you fill the car up and fill it up with a lot, it's going to burn a lot more fuel getting to where it needs to go because you're moving more mass. Okay, all right, so more force is required. Okay, and number two, so circle number one, and number two, the rate of acceleration. Okay, so if you want to accelerate quicker, you need to apply more driving force. Okay, so that's why the faster the car, the greater the acceleration force, the driving force of the car is bigger. Okay, all right, so two things, the mass and the acceleration. The mass, the heavier the object, the more force you require. The lighter the object, the less force. And the acceleration, the faster you want it to accelerate, the more force that you will be required. Okay, so there are your three there. Okay, so we can therefore create this equation. So take this down. This is your second equation. Now it's actually very similar to the previous one. Why? The previous one was weight equals mass times gravity, and weight is a force, mass is mass, and acceleration is gravity, because the gravity is acceleration due to gravity. You see, so it's actually the same equation. It's the exact same equation. It's just differently phrased. Okay, so F equals ma, force equals mass times acceleration. Okay, or F equals ma. All right, so that's your equation. Force is mass times acceleration. Okay, so that's how you calculate your force. So we have here is 4 questions. So I'll have a quick go at them. So solve the following. So pause the video and have a go. So how much force would I need to give a car of mass 210 kgs and acceleration of 3? How much force would I need to accelerate a bike 4 meters per second if the bike had a mass of 20? If the train has a mass of 500, was given a force of 20, what would acceleration be? And a car of mass, force of that, what would acceleration be? Okay. 3 out of 4. Pause the video there while I set this up and have a go. Delete that. And delete that. Okay, so I'm going to fire through them there. So I wonder, how did you get on? We'll see. Check your answers with mine. I have my calculator booted up here now. Alright, so our equation anyway is simply going to be, always state your equation, F equals MA. State that at the start, guys, because if you make a mistake, you can get 3 marks for that. Okay, alright, well, in Leaving Cert you get 3 marks for that. In Junior Cert it depends on what the question is, but generally state your equation. So how much force would I need? So 1, 2, 3, 4. So I'm on question 1. Alright, so to give a car of mass, so that's the mass, M, and acceleration of 3. So therefore, F equals, what do we say the car was? 210, and the acceleration was 3. Well, 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6. 630 newtons. Okay, so 630 newtons. That's question 1. Question 2, how much of a force would I need to accelerate a bike to 4 meters per second squared if it had a mass? So that's A, that's M. You see, what's A, what's M? So that becomes F equals 20 times 4. Let me just double check that. 20 kgs. Yeah, okay. So 4 times 0, 0. 4 times 2 is 8. 80 newtons. Okay, so that's the first 2 questions, right? So I'm going to have to rub them out there now. So you have them. Oh, no. You have them anyway on the video. You can always rewind it back to go through it. So I'm going to do the last 2 questions now. So that's question 1 and question 2 complete. So let's look at question 3. All right. If a train has a mass of 500 and was given a force of 20, what would its acceleration be? Okay, so this is slightly different. So this time we're given, so this time we're given M again, but we're given F. So, what did we say? F was 20. So therefore, number 3, 20 equals 500 multiplied by A. So what do we do here? Well, force of 20, mass of 500, you divide, you get rid of this. You want to get this to the other side, so you divide, actually, excuse me, instead of going into that detail, we'll try and make it easier. So, because this is multiplied, we bring this over and we divide it, okay? So that becomes 20 over 500 equals A. You're basically, what you're doing is divide both sides by 500. That's what you're doing. Divide both sides by 500 to get rid of that 500. Okay, I better do that in full. Okay, so people who are weak at maths, I'll do that in full. Okay, so what we're doing is divide by 500. So that becomes 20 over 500 equals 500 multiplied by A over 500. You see? So this 500 will cancel off that 500. Do you understand? Okay, so therefore we're left with 0.04 meters per second equals A. You see, that's what you're doing. You're dividing by 500, you're dividing both sides by 500. This side will cancel, this side will cancel off, leaving us with just this, which is 0.04. Okay, and the last question is pretty much the same again. Let me roll all this out. Right. So if a car of mass 100 is given a force of 40, so again we're doing the same thing again. 40 equals 100 times A. Yep. Now I don't need to show it again, but again divide both sides by 100, so that becomes 40 over 100 equals 100 times A over 100. The hundreds will cancel, and that will leave us with 0.4 again equals A. SI units, meters per second squared. And there you go. There are your 4 answers. Okay? And we're done. Okay? That's it. That's your variation of it. Now, and rub that out there. So all objects, let me see now, we're almost there. So let me see, we've got 1, 2, 3, 4, 5, 6, 7, 8, and we're on 20 minutes. All right, we're gonna plow through. This might go 30 minutes, guys, but there's no point making a third video. That'll only be about 10 minutes long. So we're gonna get through this, okay? So this, guys, what I want you to do is just click on this video link here, just showing you the idea that all objects accelerate under gravity, okay, conditions. It's an interesting video. It's about 5 minutes in length, where they have a bowling ball and a feather, and they drop them at the same time in zero gravity, and they hit the ground at the same time, okay? All right, so now we're on to the last thing, okay? Forces on elastic objects. So forces on elastic objects. Actually, you know what? We'll have to leave it there. I think we'll have to leave it there, guys, because 20 minutes, this could go on for another, you'll be looking at 35-minute video. Actually, no, we'll keep going. 35 minutes will be fine. It'll be grand. We'll watch it for a double class. So if we add a 2 kg weight to a spring, it extends 3 centimeters. When we add 4 kgs, it goes to 6. So if we add 6, it's going to go to 9. Okay, so what we can say here is this. Take down this bit here. The extension of a stretched string is directly proportional to the force that is stretching it, also known as Hooke's law. Okay, so the extension of a string is directly proportional to the force causing it. In other words, that the amount that the spring will stretch depends on how much force you're putting the string under, or the spring under. That's what it means. Okay, all right. So forces on elastic objects. So what does this mean? This means that if the force on a string doubles, so will the extension. So this means that if the force on a string doubles, so will the extension. Okay? And if the force triples, then the extension will also triple. Okay? So would this work in reverse? If we decrease it, would it go down? And the answer is yes. Okay? So here, would it work in reverse? Yes. Every action has an equal but opposite reaction. So if I add 2 kgs and it goes up by 3 centimeters, if I take off 2 kgs, it'll go down by 3 centimeters. Okay, so every action, equal but opposite reaction. It would have to, yes. Okay? Now, thinking back to our earlier topic, every force is an opposite force. If the weight is pulling down the spring, what would be pulling it up? So generally, the weight is pulling the spring down. So technically, you have this. To take this down as well, this is important. The restoring force. This is the force that tries to restore the spring to its original length. So as you add weights to the spring is actually trying to pull the weight back up. It doesn't want to be stretched. It wants to be back to normal. So it's called the restoring force because it's trying to restore the spring to its original. So take down that point as well. It's all under the same heading, guys. Okay? Now, what would happen if we stretch the spring too far? So just take down that question. Okay? Same heading, but take down that question. What would happen if we stretched a spring too far? Okay? So what happens is if you have a spring and you keep stretching it, eventually it loses its stretchability. Same with an elastic band. If you stretch an elastic band so far, it won't snap back. Okay? So things can be overstretched. Okay? What we say is when that happens, okay? So take down the last point. A spring can be damaged if it is stretched beyond its elastic limit. Okay, so it has what's called an elastic limit, where if you go beyond that, you break the spring or the string or the elastic band, and it can't snap back anymore. So you won't be able to get it to go back to its original shape. That's what happens. Okay, you've exceeded what we call the elastic limit, and it's done. Okay, so that's all that means there. Okay, all right. So take down the top first point and the last point. All right, now what I want you to do here is write this in. Experiment to investigate the relationship between the extension of a spring and the force that is stretching it. Okay, and what you will be doing, I will be explaining actually what you have to do with that. Okay, so hold tight on that. So just take that down. Okay, because what it will do is I'll probably give you an assignment in the coming days to finish this off, to actually go away and research, do up a project on how you would do this experiment. Okay. Investigate the relation between the extension of a spring and the forces that are stretching it. Okay? And of course, your results will get something like this. Okay, so your results will be something like this, where you have an extension. So as you can see, as they increase the forces gradually, the extension goes up at the same rate each time. So When they had 2 newtons, they had 4 centimeters. 4 newtons, they had 8. 6 newtons, 12. 8 newtons, 16. You see? The whole way. All right. So 2 common questions, have a go at them. If you can't figure them out, let me know. So common question number 1, friction can be useful when driving a car. Name one way in which friction is useful, and name one possible way to reduce friction. Okay, easy enough, the answers are all there. And then of course, distinguish between weight and mass. Note they said distinguish, in other words, explain the difference between the two. Okay, that's vitally important. There are 2 common questions you could get asked. All right, so let's go back to our learning intentions. Have we covered everything? We will be able to explain what a force is, how to measure it. Yes. Understand the effects. Yeah, we did it in first class. Be aware of friction, we did that. Elasticity of a spring, we just did that just there. And the elastic limit, what is the elasticity, the restoring force, and of course the elastic limit. Key words, balance we covered, force, friction, weight, and acceleration, all done. Okay, all right, so that is the topic of forces. If you have any questions, guys, leave it in the comment section below or on the Teams page, or as always, wait until we have the live class and we can go through them.